Okay, now something completely different. So this is joint work with Simão that is there, and Artur Miguel is back in Lisbon. Addressed to Artur first the questions, of course. So in two different Portuguese universities, we are doing similar work, teaching functional programming with OCaml, using Learn-OCaml to support the courses, and the same lecturers also teaching formal languages and automata theory. And since we have collaborations in other subjects, we decided to come up with this common platform to help us teaching. So the challenges we were facing in these different schools were very similar. So first, for undergraduates, these concepts are challenging and difficult not only to motivate, but also to convince students this has any interest on their training and their education. We have big enrollment numbers with respect to the number of the staff number. This gives a ratio typically of 1 to 100 in teaching staff. And of course, we couldn't be with the students to help them understanding the concepts, and we needed a platform for them to experiment. So the key motivation was coming up with a lab for students to practice the concepts. So we were building this online platform, and the main issue for us was to having something that was graphical and animated. We wanted the students to experiment with the concepts and the algorithms, and namely to execute them step by step, forward and backward, if they wanted to understand how did they get to some state, to go back in the algorithm a few steps and then forward. And so we wanted something graphical and animated in a way that the other tools we couldn't see how this could be possible. We wanted also to ease our job in the teaching staff, to have automated grading exercises and grading for the students. So we had these two sides of the project, one to build the platform and another one to integrate it with an automated grading system that would provide exercises, and the students would submit and get feedback, and for us would help us also to grade. Okay, so I think I said this, but I wanted to stress that we also believe that since we are dealing with informatics students, to understand the algorithms, they also need to program. They also need sometimes to do things a bit different, extend the algorithm, think about a different kind of situation, a slightly different version of the algorithm, and we wanted to have also integrated in the platform, namely in the grading platform, a simple way of giving programming exercises to the students. And these programming exercises would be basically specified with the usual mathematical presentations of concepts in automata theory and formal languages, and we wanted them to understand our code as close enough to the mathematical definitions. So functional programming was very natural here, and we wanted them without a very big learning curve and effort to be able of coming up with their own implementations of the new versions of the algorithm. So again, functional code was more or less obvious. Most of the students were having at the same time a course on functional programming, so that would also complement what they were doing. Okay. Moreover, we wanted also to engage the students in this practical lab. So instead of only doing exercises with pen and paper, we wanted them to feel that they were in a lab where they could experiment. And moreover, we also wanted to have, so for them it would be easy to access these labs. So we adopted a web-based solution. Okay, so I already said we have these two sides. First, the courseware, all the classroom grading, management, etc., is done in Learn-OCaml, and we have the platform for experimenting with the flat concepts. And these here the concepts are interchangeable. So we would, for instance, for regular languages, they could experiment with automata, with expression, regular expressions, with regular grammars. We wanted them to understand that there are different models for the same kind of concepts. So right now the platform is supporting this view, and we hope it will integrate more in the future. So we're calling the basic implementation of the flat concepts is a library, we call it OCaml flat, is a library that has the concepts typically as types, and then each algorithm as a function that can be used independently of the platform. And it's open source, and we encourage the students to look at the code, especially when extending the algorithms, to understand how the code is close to the definition and how can they extend and modify it. And then we have the platform, the web-based platform for them to experiment with the concepts. And as you will see, we have a bridge to connect these two, Learn-OCaml and the OFLAT web-based system, and with buttons just to pass things from one side to the other. Hopefully the demo will work and you'll see things passing from one side to the other. Let's try that. Okay. So here is the Learn-OCaml view. I think you can see it. So I logged in as a student here, and this is the student view. And right now for this presentation, we only put it there 3 exercises, but we have a long list of exercises that we present to the students. So let's start with a finite automaton exercise, and this is rather easy to define a finite automaton that will accept all possible sequences made just by the char A. So all possible sequences of A's. And we need to wait a bit so the environment is prepared. And so here I started solving the exercise. And so basically I put it at one state, maybe one state is enough. There are no transitions. And of course, I can try to grade these. This button is available for the student to receive immediately feedback. So he asks for grading to get the feedback, to understand how far is the solution from what he wants, and he gets some feedback. So some words were accepted, and that's good. Some words were rejected, and that's good, but there are many words that should be accepted and were not accepted, right? And so this is the typical feedback. We hard-coded some tests, and these hard-coded tests, you can see them there, and the student will try the solution against these hard-coded tests. Now, instead of solving here the exercise, I could just start editing here, but instead of solving here the exercise, the idea is to use this button, or flat, and this button is supposed to launch the web platform via this bus that connects the two. And now I have already loaded there the solution that was written in the Learn-OCaml. I know this is not good enough. There are many tests that were failed. I can try to understand. So why is it not accepting 1A? Basically, I don't even have a transition for A. So let's say that I'm not very confident with these concepts as a student. And so I say, maybe I need a transition. So let me add here a state, another state. and let's call this state S. Imagination running wild. And I add maybe a transition. So now I want a transition, add transition, and I add a transition there. And of course, it should do A. Okay, but I immediately understand I want to do as many A's as possible. So this is probably not good enough. Just doing one A, let me get back and do another, okay? Let me get back and do another A. Okay, looks good. Let me see. Now, I start suspecting that maybe words of odd length will not be accepted. Let me see. If I only do one A, what happens? If I only do one A, I'm in the S state. Okay, and this one does not accept only one A. Let me make it final. If I make it final, oh gosh, sorry. This is actually, so I'm blaming the non-OCaml part of the application. This is Cytoscape, a Java library. So anyway, you can't see it all, but let me do something different. Show you in JSON the representation of the automata. And okay, it looks good. We have two states and transitions. Let me try now with this word that was not being accepted. So I try again only one A, and I do the step. Okay, it was already in the step. Green is good, was accepted. Okay, so let me try to submit this, Learn-OCaml. I touch this button. Sorry, the button doesn't really have a feedback, but I suspect it worked. Yeah, the solution is already there. So let me grade. So we upload the solution in the Learn-OCaml. Let's grade it and see what's going on. And almost everything, but acceptance of the empty word failed and acceptance of two A's failed. Maybe I forgot the first state to be final. Anyway, I'll not bother you anymore with this exercise. I need to work a bit more, think about it at home. Let's go back to, say, regular expressions now, okay? So regular expressions, again, this is exactly the same. We get a solution, so I loaded here a solution, again, just doing one A. Grading will give basically the same result. I don't bother you with this. Let's move to the web platform. Okay, just one A. I immediately understand, I know it's not enough. Let me edit it. What I want probably is a star. Let me do a star. Okay, just have there an AST representation of the regular expression. This was our choice. If you have suggestions of doing something better, please just tell us. And now let me test a better word. 3 A's, does it work? 3 A's, okay. There's a way of accepting it. Fine, so let me get back to Learn-OCaml. Okay, I got the solution, great. Probably it will go through the system and I get everything green, hopefully. Yes, great. So some points already for the final mark. Final exercise, if I have time yet, a context-free grammar, a regular grammar to accept this. And we do basically the same. So in the regular grammar, again, we have, let me call now your attention. We have in this window on the left-hand side, as you see, it's a bit of OCaml code, but the students don't really need to or even the staff doesn't really need to understand that. We try to hide as much as possible that the fact that this is OCaml code, because since it is an OFLAT, a course about flat concepts, we don't want to force students or to make them think the only way of dealing with these concepts is via OCaml. So we try to make it a bit abstract. Okay, and again, you pass to the other side, you will see some presentation of the grammar. Now I forgot to read what is the exercise. What does it say? It's no longer here. I don't want to go back here to read the exercise, but I guess it is the well-balanced, should be something like the well-balanced grammar language. So I can edit here the model. I can edit and write the rules I believe are appropriate. So we have the empty word. We should have something like, of course, opening and closing. And let's say, okay, applying them one to the other. It looks good. As you see, there is a lot of information on the side. If I want to try one word, probably I need to convert this to some format anyway. Again, I can go back and have it here already charged.
You should try to wrap up after this example.
Okay, so finishing with the demo, I'm really surprised it works without bugs. It's not a movie. Just call your attention that we didn't do a lot of things, namely assessment. So we really need to understand if this is actually useful, not only in the learning process of the students, with respect to the usual kind of classes of just using the blackboard or paper and pen. And another thing we need to assess is with respect to other existing tools. JFlap is an impressive one, really very comprehensive in flat concepts. With respect to these other existing tools, what is the gain of using our approach? Of course, extend with more concepts and have other people either than us that developed it, either people in different universities using it, and as third persons trying to understand what are the difficulties and things that are not intuitive. Bugs are for free. They are there everywhere, I guess. So they didn't pop up today because I rehearsed this well enough, but they will pop up for sure if you start trying it. And since it is open source, take it and modify it, contribute. Thank you.